Well, welcome back again. And one final point I wanted to make with JavaScript is a security measure in the Java is about a security measure in the Java development environment. And that's called the sandbox. This is a set of rules that are used when creating an applet that prevents certain functions when the applet is sent as part of the web page to make it dynamic, right? Which is an added security feature, something I like about JavaScript. Now, connecting to databases. Most web pages that display company information to users, we know are stored on a database server. So the technology used to connect the web application to a database might vary depending on the operating system. But the theory is generally the same along the way. Now, an open database connectivity, or ODBC, this is a standard developed by SQL Access Group, and it allows the application to access data stored in a database management system, or DBMS, such as and other key features of the OBDC, right? Is this OBDC interface? That was the key function that I wanted to mention. And it accomplishes much of the interoperability, right? As the slide says, it allows applications to access the data stored in a database management system, right? Or any system that can frankly understand these ODBC commands, right? Interoperability is really the key. It's standardizing the representations of the data. Now, the object linking and embedding database, which is OLEDB, right? This is a set of interfaces that enables applications to access data stored in the DBMS, right? Designed by Microsoft, it's fast, it's slick, relies on connection strings, and different providers are able to use it, which is nice. Now, ActiveX data objects. So in January 2020, Siemens did address, the company Siemens, addressed several vulnerabilities and warned customers about the security risks associated with the use of ActiveX in industrial products. So Microsoft's ActiveX controls make it possible now for websites to provide certain types of content, such as videos and games and things like that. And they allowed the users to interact with certain types of elements in the browser, such as toolbars, right? However, ActiveX has been known to pose serious security risks, and it's currently only supported by Microsoft, I think, on Internet Explorer. I'm not sure if their new one does. Their new Edge, it's called, I think. So ActiveX is not supported by their browsers, such as Chrome, though, Safari, or Firefox. This I know for sure. Even Microsoft has advised IE11 users not to disable security settings. So you as a security tester, one of the first things you would want to do is check the security settings of the browsers, right? So you, in IE11, Microsoft tells you not to disable the security settings that prevent the downloading and execution of ActiveX controls unless absolutely necessary. So malicious hackers can use ActiveX to collect information about a user, to install malware, or even to take control of a device, right? So, things you want to be cautious about. Now, in understanding web application vulnerabilities, many platforms and program languages can be used to design a website. So regardless of the security professionals need to access the system and examine the potential methods for attacking. This is what you would be doing. So network security is essential to protect company data and resources from attack. We all agree to that. Application security, right? AppSec, DevSec, right? It's sometimes overlooked, and I want to warn a caution flag against that. No matter how efficient companies' firewalls are, or IDSs, or IPSs, most systems allow content of HTTP traffic. Therefore, an attacker can bypass supposed security boundaries as well as many OS hardening efforts, right? So simply stated, the network layer protection doesn't always prevent application layer attacks, right? All an attacker needs is an understanding of some basic programming concepts or scripting languages. To add mayhem to that, I would offer attackers usually don't need specific tools, and detection of a manual attack on a web application is often difficult. After attackers gain control over the web server, they can use a number of post-exploitation actions, right? Including defacing the website, destroying the database, or selling its contents, right? Gaining control, launching secondary attacks, which we're always concerned with, or attempting to gain access to other servers, etc. Okay. Now, luckily there's an organization out there to help us and as security professionals to understand the vulnerabilities in web applications. And so OWASP, Open Web Application Security Project, is a not-for-profit foundation dedicated to helping us find and fight the causes of web application vulnerabilities. OWASP, which can be found at www.owasp.org, it publishes the 10 most critical web application security risks. It does it in white papers and other things, right? And so this can be built. These functions have been built into the payment card industry, PCI DSS standards. That's data security standard, and the PCI DSS is the requirement for all businesses that sell products online, right? So you'll want to check out that website. Okay. All right. There are application countermeasures. I'm going to take a pause and then we'll come back to that in just a minute. So as a security tester, we might need to analyze the vulnerabilities in an OWASP top 10 list, right? So for example, injection vulnerabilities involve validating and testing the inputs to make sure that the applications handle them properly, and of course then doing error handling, right? Very important, so the system doesn't crash, stops it. We want to do authentication flaws and weaknesses, which we've addressed previously. There's a cross-site scripting, XSS as it's abbreviated. This can be addressed with, for example, input validation. Insecure direct object reference would be another one. We just talked about some of that. Security misconfigurations, right? So you would want to require an initial security baseline as a security tester. Then you'd want to have a configuration baseline and, of course, add patching to that to avoid security misconfigurations. This will include operating systems, web applications, web servers, even services used for maintenance. Sensitive data exposure makes me think that this should lead us to maybe encryption as a potential solution. Also, I would look at client-side exposure of information that is cached, right? Or server-side encryption of data at rest should be used to protect sensitive data such as passwords and customer information, right? There's a missing function level access control, right? Which is described in other sections that we've talked about, and that means application does not properly verify that users are authorized to view the information, right? So we want to be careful there. Cross-site request forgery, XSS forgery as it's abbreviated, that's about cookies, right? So one of the things I like to do is limit the life of a cookie, right? So that it can't be copied and forged, used elsewhere, like it's me. Using components with known vulnerabilities is also on the top 10 list of OWASP. This is like the third-party libraries, OS's databases and applications, etc. And of course, unvalidated redirects and requests can make use of a whitelist, which we talked about, right? Unvalidated redirect applications should only allow redirects to a whitelist of target URLs would be a good point. Now, there's also the WebGoat project. So WebGoat is an online utility that helps beginning security testers understand the web application vulnerabilities. So OWASP developed this WebGoat project to help security testers learn how to conduct vulnerability testing on web applications. Invaluable, right? And so I'm going to just do a quick pause and make sure I post a play. It doesn't give you the answers. And so there you go. Let me get rid of this. There we go. So there you go. I've posted that link on site. It's one place. You could Google your own answers to the WebGoat project if you have trouble following it, because they don't provide the answers, right? But it does help security testers learn how to conduct vulnerability testing on web applications. So you will find it invaluable. Now, there are application countermeasures, right? So we want to make sure we set up our client-server configuration so that we can sniff traffic containing credentials to a website, right? Because launching a DOS attack, denial of service, can happen, for example, by creating too many concurrent logons, right? Consider how you would break an authentication scheme or steal credit cards from a database or deface a website in that approach, right? And so application vulnerabilities and countermeasures can also be found at these sites here that I've posted just by doing a simple Google search, and very interesting. You are welcome to find your own. Make sure you do your own check of security before you access those sites. Okay, so a web application test execution then. There are two techniques by which an application can be tested. I've mentioned the static application testing, or SAST, is one approach, and dynamic application testing, DAST, is the other. We've kind of touched on these earlier in Chapter 10. SAST is analyzing an application source code for vulnerabilities. It's a reliable way to enumerate most application vulnerabilities. DAST is an analysis of running applications, right? If source code is not available to the tester, DAST is all you're going to be able to perform. Okay, so an interesting conversation there. Be aware of that. So information gathering and architecture mapping, right? There are a number of security testing checklists and guides that you can use. You can walk through as a security tester through this dynamic testing, right? And they're based on generally the OWSAP Web Application Pen Test Guide, right? Which I'm going to pause and put up here for you. So this is the link to the site for the OWSAP Web Application Pen Test Guide. Make sure you go there, right? Remember that most of the time, teams are used when performing security testing. You're part of a team, right? And so security testers will be asking the same questions, and you'll be working with each other to answer them. Does the application have a database? Does the application require authentication? Is it static or dynamic pages? What languages are used? Are there differences between the web browser and the application designed to stop attacks from occurring? Those sort of things. Very interesting. Now, platform security configuration is where we'll come back in a moment for our last section of Chapter 10. See you in a little bit.